All right, in this video, we're going to be looking at the warm-up from class, and we've got this reaction over here. We want to write the K expression for this reaction as our first job. So a KC expression, some things to remember when you're writing any K expression. There's three things to remember. One is that it's products over reactants, that the coefficients become the exponents, and you leave out any solids and liquids. Okay, so it's products over reactants. So our product is CH3OH, and we're writing a KC expression, so I want to use these square brackets. These square brackets represent concentration in molarity. And the coefficient here is a 1, so we're just going to leave that there. And then the reactants are carbon monoxide and hydrogen. The hydrogen has a 2 coefficient, so we're going to square it. There were no solids and liquids in this reaction, so we don't have to worry about our third bullet point there. All right, so this is what we call a K expression. This is a KC expression. By the way, if you had been asked to write a KP expression, the way that that differs is we just use different symbols. We use this P symbol to represent the partial pressure of CH3OH, that's methanol, divided by the partial pressure of CO and the partial pressure of H2 squared. When you're doing KP expressions and you're solve for the value of KP, you have to put in pressures measured in atmospheres. So it can't be in millimeters mercury or PSI, it has to be in atmospheres. So those are our different K expressions. We're trying to find the value of Kc here. We're going to just plug in our molarity values from equilibrium. So it looks like at equilibrium, our product is 0.185 molar, and our reactants are 0.105 molar and 0.114 molar, and that one I'm going to square. And then you're going to stop and plug this in your calculator. 0.185 divided by, which I'm going to take a moment to do right now. 4, and we should be getting 136. And if you're following units, you would expect that our answer should have units of like 1 over molarity squared. It doesn't. The reason why is just by definition, K values do not have units. So all equilibrium constants are unitless, no matter what the setup is over here on the left. So yay, you don't have to worry about units with this one. Okay, now let's think about how this value of K relates to thermodynamic favorability, which is what we talked about last unit. So if you think about what we know here, the K value is big. It's much larger than 1. What does that mean? Well, that means we have mostly products at equilibrium. Or in other words, most of our reactants turned into products. And so if we think about what does that tell us about the forward reaction, which is this reaction right here, going from reactants to products. Well, if most of our reactants turn into products, this seems like this is a favorable reaction. It's energetically favorable. It seems to be happening spontaneously. And if a process is energetically favorable, we know its delta G value is negative. So it turns out we're going to see there's a connection here. When our K value is greater than 1 and you have mostly products at equilibrium, that is an indication that your reaction is thermodynamically favorable. That's why you end up with mostly products. All right. So thank you for listening.